In the last video, we looked at the graphics card 1. In this video, we're going to look at a new instruction called Pixel, which we can use along with that graphics card. Now, we haven't covered the assembler yet in the course, and we will cover that in the next section. But it's still useful for us just to write the little bit of assembly language just now, and you can see me writing it, and you can see me assembling it and then loading it in. But don't worry about it for the moment. You can just watch me doing it, and in the next section, once you went through the assembler, retrospectively you can come back and do this for yourself as well. So if I want to write the assembly language, I just need a text editor. Okay. Now we're going to start off with the beginning address of our program, which is 0 cross 8000. So that's 8000 in hex. Now the pixel command just looks like this. Pixel, and then the next number is the memory mapped IO location for graphics card 1, which is FFF5, and then the next value is the location of the colour. So the location of the colour is going to be register R0, and the location of the XY coordinate is the next one, which will be register R1. And of course you can change these to whichever register you want. Now a thing to note here is that this value here is actually a hex value, so you've got to tell the assembler it's hex. So it has to start with a 0 and a cross. So that means it's a hex value. And then we can end this. Now it's not going to do anything just with this piece of code, because right now we don't have a colour in register R0 or a position in register R1. But we can put one in using our data command. So we can put in data, and we can choose a value for the colour. Now the colour I'm going to choose is FF12, which is almost white, and we'll put that into register R0. Now the position, we'll make the position 1250, and we'll put that into register R1. So they're pretty random colour and position values, just to show you how it's working. Now again, these are hex values, so we've got to tell the assembler, so 0x tells it it's a hex number. But remember, the value for the colour and the value for the position are just literal numbers. They don't refer to a memory location. So if they're literal numbers, we have to put a hash in front of them. So this is our little assembly language code using the new command Pixel. Now you'll see the new command Pixel in a moment when I'll open up the spreadsheet. But for now, we can save this. And I have my assembler here in Python, and all I need to do is press the run command, and it will generate the machine code for us. Now again, don't worry about this, it's covered in the next section, and you can go back yourself and have a play with this once you've gone over the assembly language section. But I can press this run, and it generates the assembly language code, and this is assembly language code here. Now it also outputs it to a file, so it means that I can then just go in to the CPU, edit contents, and open up that file, and this is the file here. So that's the file here, all ready to use. Now I will run this here a little bit slower, so it's at 4 kilohertz. Simulate tick enabled, so it'll put a number into register R0, which will be the colour, a number into register R1, which will be the position, and then it will run through the pixel command. So tick enabled. So you can see the values heading in here. So FF12 is the colour, 1250 is the position. It's worked all the way through, it's got to the end of the program, and it's put a little dot on the screen. So not the most exciting thing in the world, but it's a start. Now the interesting thing about this is that if we have a pixel command, then if we wanted to build up a whole graphics library, we could gradually build on that pixel command and make more and more interesting graphics. For example, if we wanted to draw a straight line between 2 points, we could have a line command. And in that line command, what we do is we write the code that takes the pixel command and continually puts out pixels from the beginning location to the end location. And we can take that piece of code and we can save it in the ROM as a subroutine. So that whenever we call up the line command, we put in the line, we put the starting position, the end position and the colour, and it goes and it runs through a subroutine which is the pixel command drawing all the individual pixels from one point to another. So that would allow us to draw a horizontal line. We could draw a vertical line. So that means if we can draw a horizontal line and vertical line, we can take the line command and we can put that line command into a ROM location as a little subroutine. And we can draw, for example, a square, and a square would be made up of the 2 corners. And we could generate that square using the line command, which uses the pixel command. And through that hierarchy, we could build up a little graphics library. Now that's not what we're going to do here because we just don't have enough time in the course to do all of that, okay? But it's stuff that I will add in over time, and I'll put more and more videos on because it's relatively straightforward. It's a relatively straightforward thing to do. But it would just take so much more of my time explaining it. So that's the direction that you can go in with this simple little command. Now if you go into the resources section, you'll see we have the Excel spreadsheet for generating the microcode, and it's been updated with the pixel command. So if you head down right to the very bottom, now I'll get rid of my image, or I'll move it over to the other side of the screen here. So you see the pixel command at the bottom, so that's command number 114. Now it's a complicated command this, and it takes up 14 of a total of 16 possible micro instructions that builds up this one single instruction. Now I'm not going to go through every line of this code because it would just take too long and it's just not that interesting, but I think it's a good thing to pick out a couple of these commands in the spreadsheet. You don't need to do it with all of them, but pick out a couple of commands and then see if you can work out from each line of the microcode how it builds up the actual command. So this particular one would be a more difficult one to start with. But the idea behind this microcode in essence is it's going to have to provide all the necessary sets and enables in order for us to allow us to function that little graphics card which we've seen in the last video. So that is, it's going to have to put out the value FFF5 so we can pick the card. And once it's put that out, it's going to have to take the value from register R0 and put that onto the bus so that that value can then be saved in the little register in the graphics card 1. And then it's going to have to do the sets twice, so it has to set that value once in that color register in the graphics card, and then it's going to have to go to register 1 and take the position, put that onto the bus, and it's going to have to then set that one into the other card, and then it's going to have to go through the output to the bus and then into the display. So it has to follow these routes for each of the lines here within the microcode. So you've seen this microcode in a couple of other places, okay? But it's well worthwhile picking a couple and going over them. Now in the next video, we will write a more complicated assembly language program using this pixel command. And it will show you a little bit more of the power of our assembler as well. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.